In this video, we are going to explain about a project titled Deep Learning Based Gaucoma Detection with Cropped Optic Disc and Blood Vessel Segmentation. So now coming to the introduction part. Deep learning has become a revolutionary influence in the field of medical image analysis, transforming the way diseases are detected and diagnosed. Specifically in ophthalmology, where timely identification is crucial for preventing irreversible vision impairment, there is considerable interest in approaches based on deep learning. Our proposed techniques harnesses the capabilities of deep learning, concentrating on the detailed examination of cropped optic cup and disc areas, complemented by accurate segmentation of blood vessels. So now coming to the objective part for this project is to propel the domain of glaucoma detection forward by employing the capabilities embedded in deep learning methodology. By leveraging state-of-the-art algorithms, our inspiration is to augment the precision and effectiveness of glaucoma diagnosis with a specific focus on its initial phases wherein timely intervention can profoundly influence patient outcomes. These anatomical structures serve as well-established indicators of glaucometer alterations, and overarching objective is to deploy sophisticated deep learning techniques to meticulously identify and evaluate these regions. Now coming to the requirements part, here we have two types of requirements, the hardware requirements and the software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy and Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Cquant for visualization are important. Second, here we have data exploration. In this phase, the glaucoma dataset is examined to understand its structure, contents, and characteristics. This step helps in gaining insights into the dataset and is crucial for making informed decisions during subsequent stages of the process. The next here we have image processing. Using the image data generator, various transformations are applied to the images in the glaucoma dataset. These transformations include rescaling the image. The next here we have rotating the image, zooming the image, horizontal flip, and reshaping the image. These steps aim to augment the dataset and improve the model's generalization. The next we have data extraction into training and validation sets. The processed data is then divided into training and validation sets. The training set is used to train the data learning models, while the validation set helps assess the model's performance on unseen data. Then we have building the model. Multiple deep learning models are constructed to tackle the glaucoma detection task. These models include DenseNet, Inception, ResNet v2, CNN, MobileNet v3, MobileNet v2, EfficientNet v3, GoogleNet, and Exception. Each model architecture brings its unique characteristics to the task. Then we have training and dumping the model. The models are trained using the training dataset, and the trained models are saved or dumped for future use. Training involves optimizing the model's parameters based on the training data to improve its performance. Then we have Flask framework, local host, sign up and sign in with SQLite 3. A Flask framework is employed to create a local web application. This application includes features for user sign up and sign in using an SQLite 3 database, ensuring secure and personalized access. Then we have user uploads the image for analysis. Users can upload images through the web interface for analysis. This step involves handling file uploads and ensuring that the uploaded data is processed securely. Then we have the given images pre-processed. So the image is getting processed. The uploaded image undergoes the pre-processing steps, including converting it to a format compatible with the deep learning models using Keras, image to array conversion, and reshaping the image to match the input requirements of the trained model. Then we have trained model is used for predicting user data. The pre-processed image is fed into the previously trained deep learning models to make predictions about whether it indicates sign of glaucoma. The models utilize the knowledge gained during training to classify the given image. The next we have predict with model for outcome displaying the final outcome. The final step involves presenting the presentation prediction outcome to the user through the web interface. This could include displaying whether the uploaded image suggests the presence of glaucoma or not, along with any additional relevant information or visualization. So now coming to the execution part, To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Another folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. And the next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute in individual cells code, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. Then we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path from here. Open the Anaconda prompt. Now type the cd command followed by a space and just paste the path over here. Now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just select this link and copy this link and paste it into any of the browsers. Here I am using Chrome. Now just hit the enter button. So here this is our home page for this site. It is about the glaucoma detection, image processing and deep learning. Now click on the sign up button. Here you have to enter your username, email, phone number and your password to do the registration. I have already done the registration, so I am clicking on sign in button. Enter the username and the password over here which you have created while doing the registration and simply click on login button. Click on OK and here you can see about the glaucoma detection. Click on choose file. So let me choose a file from this. So here you can see that I am choosing this image over here and now click on open button. Click on upload. So by scrolling down below here you can see that this is our uploaded image and it is showing for the given input image the diagnosis site is the patient is identified as glaucomatic negative. By clicking on the try again option, you can upload the file from here. Suppose I am choosing this image, click on open button and upload it. So depending upon the image we have provided over here, it will detect whether the glaucoma is there or not. So it will detect it as negative. By clicking on the sign out button, you can simply log out with this, and this is for the graph option and this is for the prediction. We have already done with the prediction. Now click on graph button. So you can see that there are many different graphs based upon the algorithms. It predicts whether the accuracy of which algorithm is higher and which algorithm has lower accuracy. So now just simply click on the sign out button to get log out with this. So now coming back to the conclusion part. In summary, our innovative methodology for glaucoma detection grounded in deep learning stands as a noteworthy advancement in the field of ophthalmic diagnostics. Our focus on meticulous analysis, specifically targeting the cropped optic cup and disc regions in conjunction with intricate blood vessel segmentation, reflects a substantial leap forward in the precision of our diagnostic capabilities. By harnessing cutting-edge deep learning algorithms, we have dedicated our efforts to elevate the sensitivity and specificity of glaucoma detection with a pronounced emphasis on the early stages of the condition. This commitment to refining diagnostic accuracy holds promising implications for timely intervention and improved patient outcomes in the intricate landscape of ophthalmological health. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.